So we now begin part 2 of the class, which is we've done our experiment and we've collected our data. What do you do with the data? So the first thing we're going to talk about is organizing and presenting it, and then we'll spend much of the rest of the class talking about doing calculations and analyzing. But for now, organizing and presenting. Because if you can't share your work with other people so they understand it, then what was the point? Statistics is a very, very applied class, and for those reasons, you're likely to encounter these sorts of calculations and projects in a real-world setting. So, like for example, at your job or doing research. So ideally, you'd like to be able to present your data in a nice and convincing way. Okay. So the first thing we're going to talk about is presenting qualitative data. Remember, those are words. All right. So a lot of these presentations formats, you have to understand what is a frequency distribution. So a frequency distribution records how often does each data value appear. So let's go back to the question from the first day survey. Is this your first semester at BMCC? The results from that survey was one person said yes and 3 people said no. So how do we record that data down? Well, we're going to record exactly this. Each data value and how often it appears. So we just make a very simple table. Data value and frequency. And what does frequency mean? How often it appears. Right. Okay. So what's the first data value? What are the possible data values for this question? What are possible responses? That's your data. So the possible data values are yes and no. Thank you, G. Okay. So for yes, what was the frequency? The frequency was 1. And then for no, the frequency is going to be 30. That's it. This is, albeit a very simple one, but this is a frequency distribution. Now, suppose I tell you I did a survey and I did a survey asking people, is this your first semester at BMCC, and 30 people said no. Is that a lot? Yes, no? Why not? I'm sorry? Yes. What if I asked 18,000 students and 30 said no? So the answer is it depends. So how do we capture that information? That's called a relative frequency. Relative frequency. Because if we want to know if it was basically we want to know it's 30 a lot. And the way to capture that is we say 30 out of what? So relative frequency is your frequency divided by your sample size. So in this case, so let's fill this in. So in this case, what's our sample size? How many people were asked? 31. So let's fill in this over here. Relative frequency. Now, what is the relative frequency for yes? That's just the frequency. What is the relative frequency? 1 out divided by 31. It's 1 out of 31. What's the relative frequency for no? And if you were to add all those up, what would you get? 31 out of 31, also known as 1. Now, to do this comparison, 1 out of 31 doesn't really give a nice idea. Or what if it said 7 out of 31? It's a fraction, so it's nice, but doesn't really give you a sense of how big it is. So what can we convert this to? We can convert this to a percentage, absolutely. So I'll pull up my handy dandy spreadsheet. Wait, let me shrink this out. There we go. So, and you'll notice that I use, especially since this is stats class, and we're gonna be using spreadsheets quite a lot. I've gotten used to using my spreadsheet to do calculations, and you might as well. So let's just do 1 out of 31. 1 divided by 31. Ooh. We don't like all those decimal points. We don't need all those. So another very important button that you'll get used to using is the increase or decrease number of decimal places. It's these two buttons right here. So percents, we typically use how many places? 2 places. So let me do that. To 2 places. So to 2 places, this is 0.03. 0.03. And as a percent, what is that? It's what? 3%. And then 30 out of 31 is going to be, sorry? 97 bananas? 97 what? Percent. And what is it going to be as a decimal? 0.97. Okay. Now, a quick word about this. I've written down the relative frequency 3 different ways. So you should be familiar, since you all have graduated from high school, you should be familiar with these 3 different ones. But for our purposes, there's something more subtle going on. Each one has particular strengths and weaknesses in terms of using it. When we decided to write down the relative frequency, what was the first and easiest one to write down? The fraction. Because to write down the fraction, the numbers are already there. You just write them down. However, for comparison's sake, it wasn't the best thing. So what do we like to sort of talk about in common language when you're having a discussion? What do you prefer using? Percentage. Everyone typically talks about percentage. Later on, we're going to want to do calculations using these numbers. Which one is the easiest to do calculations with? Do you have a calculator that can calculate in percents? Like 97%? Most calculators don't have that. The easiest thing to do calculations with is the decimal. So, particularly as a mathematician, for that reason, you'll see me, usually I'll write down the decimal. Right. However, you'll note, so again, to sum up, each of these representations is best to use at certain times. Okay. So, why don't y'all make a frequency distribution table for what is your major? Okay. And to help you out, I should probably show you the data. So there's the data. That might be a bit small. All right. Oh. Okay. So go ahead. There's your data. Make a table. Okay. Oops. There we go. Okay. So how do we fill this table out? So how do we fill this table out? What goes in the table?
Major, computer,
Uh-huh.
ACC, science, LA,
LA is for liberal arts.
HIT, business,
Health, information technology.
and then business.
And business. Okay. And now?
1, 2, 1, 2, 2, 1.
Okay. And as an extra bonus, we can also include the relative frequencies. Now, in order to find the relative frequency, what do you need? You need to add it all up.
6, 1.
So that's assuming we have a big number.
I'm sorry?
That's assuming that everybody ends.
This is, yeah, we're just using the data that we have. That's correct. Okay. So if you total it, what do you get? You get 9. So what's the relative frequency for computers? 1 out of 9. Accounting, 2 out of 9. And if you add those all up, you get 1. Okay. Now, because I'd like to have this later, we're going to write this down as a decimal. So as a decimal, what do we have for computers? 0.11, 0.22, 0.11, 0.22, 0.22, 0.11. And of course, all of that adds up to?
1. I know, 1.4.
Yeah. This actually adds up to 0.99. And what's the problem? Yes. We rounded it off. Okay. So due to rounding, you're going to get 0.99. But you know, we know it's supposed to be 1. If we did it more precisely, or if we did it to more decimal places, we could get 1. Okay. We'll come back to this. Okay. Next, a bar graph. So how do we make a bar graph for this? What is your major data? What's the first thing I have to do? First, we put the majors on the bottom. Got to know what you're drawing bars for. So on the bottom, you have major. And we have computers. What else? Accounting, science, liberal arts, HIT, and business. Okay. So the bar for computers. 1.
2, 1, 2, 2.
Okay. Is that sufficiently straightforward? Any questions? Okay. All right. Now let's consider this other bar graph. This is a bar graph of number of people in poverty on the Lower East Side. So in this case, each category is the year, and then the frequency represents the number of people that year in poverty. So what can you tell me right away from looking at this graph? I'm sorry? Okay. Well, that's just my choice. What can you tell me in terms of information? I'm sorry? Right. The most people in poverty was in the year 2005. Can you see that immediately? All right. So a bar graph is really good for that. What could you not tell me? You can't tell me exactly how many people. Approximately in 2005, how many people? Approximately 6,000. But you can't tell me exactly, but we can fix that. So this is why a lot of times people choose to put a little label on top so that you can say exactly. But you still have the nice impact of the visual presentation. Okay.
And you wouldn't do that for all, just
Do you need to do it for the what is your major chart?
no, I mean, you talked about the graph about we would put the number above it.
Yes, for all of them. Yes. Okay. Next, pie chart. So let's do a pie chart for the same thing. Like this. Okay, now what do I have to do with my pie? Okay, it's the exact same data. We're using this data to make a pie chart. So what do I have to do? Okay. Well, I have the decimals, so I basically have the percentages. So what do I do with that? So, I'm sorry? Divide the pie by 9. I need 9 slices. Yes. Yep. So, thanks to my fantastic artistic skills, we now have that. Let me even that off a bit. Okay. All right, so now what do I have to do? Well, there we go. Okay. So what do I label? How do I do this?
It's
2%. Okay. So which one is account? So accounting gets a big slice, and that's 22%. And what else do we have? And HIT gets a big slice? Okay. And then what do we have in the small slices? Computers 11%, science 11%, and business 11. Okay. Oh, right. So, and notice in this situation, it kind of makes sense to us to label the things with the percentages. You could label them with the total frequency. Either way, it's whatever you think is more appropriate. The textbook makes a big deal about calculating exactly how big the slices need to be, how many degrees, all that sort of thing. Doesn't matter. Make a sketch. That's what we need. And if there happens to be such a question on the homework, like a subpart, just skip it, don't worry. Okay. So any questions about these things? Ready for the next thing? Are you ready for the next thing?
Yes.
Super. Okay. All right. So next up,